Question number 20. For each series, evaluate the sum or show that it diverges. So the reason all of these are together, I put together this 5-part problem, these are all geometric series of one form or another. So a geometric series, it looks like the sum from n from 0 to infinity of c times r to the n. So this is equal to c divided by 1 minus r if absolute value r is less than 1. If absolute value of r is equal to 1 or greater than 1, then the series is going to diverge. In terms of what c and r are here, c is the first term of your series, which might not be your series. I wrote this out here, n is equal to 0. Your series might not be indexed starting at 0, so you have to be careful of that. And then r is the ratio, the common ratio between terms. Okay, so let's jump into things, and for each one of these series, we're going to try to figure out what's the first term and what's the common ratio. And if the ratio is less than 1 absolute value, we can just plop things into this formula and be done with it. Okay, first series, the sum of n from 0 to infinity of 7 divided by 3 to the n. We're going to rewrite this as 7 times 1/3 to the n. And so this very quickly allows us to see that we have r is equal to 1/3. What is the first term? What is c? When we plop in n is equal to 0 in here, we get 7 times 1/3 to the 0, which is just 7. So c is 7, r is 1/3, r is less than 1 absolute value, so we can say that this is, so that was equal to that. So the overall series, the sum from n from 0 to infinity of 7 over 3 to the n is equal to 7 divided by 1 minus 1/3. And if you simplify things, this ends up as 21 over 2. Okay, problem number 2. E to the 2 minus 5n, sum of n from 1 to infinity of that. So this might look a little bit weirder here. I'm going to rewrite this as, rewrite e to the 2 minus 5n. I'm going to rewrite it as e squared times e to the minus 5n, which I'm going to further rewrite as e squared times e to the minus 5 to the nth power. So from this, we can see what's our common ratio. Our common ratio r is e to the minus 5th power. How about the first term? The first term is when n is equal to 1. So I plop 1 in here. I get e to the 2 minus 5. E to the 2 minus 5 is e to the minus 3. Okay, so what does this give me here? So r is less than 1 in absolute value, so I can plop things in and say that this entire series is equal to c, e to the minus 3 divided by 1 minus r, e to the minus 5. If we don't like negative exponents in our denominator and our numerator, we can multiply top and bottom by e to the 5th. And obtain e squared over e to the 5th minus 1. Okay, 2 down, 3 to go. Let's look at this next one. Sum of n from 3 to infinity of 2 to the 2n plus 1 divided by 3 to the n. So when I look at the individual terms here, so this is going to be 2 to the 2n plus 1, 2 to the 2n times 2 divided by 3 to the n. 2 to the 2n is just going to be 4 to the n. And I've got a 4 to the n upstairs, a 3 to the n downstairs. I'm going to rewrite this as 4/3 to the n. What's the advantage here? Well, here is my ratio. My ratio R is 4/3, but look up here. 4/3 is bigger than 1 in absolute value, and so this is enough for me to conclude that this is a divergent geometric series because the common ratio is bigger than 1 in absolute value. Okay, let's take a look at the back page here. As 4th and 5th. The sum of n from 4 to infinity of 2 to the n plus 1 divided by 3 to the 2n plus 1. So it's very similar looking. So when we rewrite 2 to the n plus 1 divided by 3 to the 2n plus 1, 2 to the n times 2 divided by 3 to the 2n times 3. So that's 2/3 times 3 to the 2n is 9 to the n, 3 squared to the n. So we have 2/3 times 2/9 to the n. Okay, so I can write down my C and my R now. R is 2/9, less than 1 absolute value. Life is good. What's our initial term? We need to plug in n is equal to 4 in here. So when we plug in n is equal to 4 into our general term, we have 2 to the 4 plus 1 is 2 to the 5th, divided by 3 to the 2 times 4 plus 1, 3 to the 8 plus 1, 3 to the 9th. So now we can say for our entire series here, this is going to be C over 1 minus R. So that's going to be 2 to the 5th divided by 3 to the 9th. All of that over 1 minus 2/9. When you crunch this out, you end up with 2 to the 5th divided by 7 times 3 to the 7th. And that is 32 over 15,309. Okay, one last question here. The sum of n from 6 to infinity of 2 to the n plus 1 plus 3 to the n divided by 5 to the n minus 2. When we have a plus in the numerator, we're going to break this up into two separate sums. So what I want to do here is I want to rewrite this as sum of n from 6 to infinity of 2 to the n plus 1 divided by 5 to the n minus 2 plus the sum from n from 6 to infinity of 3 to the n divided by 5 to the n minus 2. I'm allowed to break things up in this way if both of these series respectively converge, and we will see they will both converge, so this will be allowed. Okay, so we have to crunch these out separately. So for the 2 to the n plus 1 divided by 5 to the n minus 2, we can rewrite this as 2 to the n times 2 divided by 5 to the n times 5 to the minus 2. And so we end up with 2/5 to the n times 2 over 5 to the minus 2. So this is going to have common ratio 2/5. For the 3 to the n divided by 5 to the n minus 2, so this is going to be 3/5 to the n times 1 over 5 to the minus 2. For first terms here, the C here, when we plug in n is equal to 6, let me label here, R here, 2/5 and 3/5. The C here is going to be 2 to the 7th divided by 5 to the 4th. When I plug in 6 upstairs and downstairs. The C for this one, when I plug in 6, I think I might have said 5, when I plug in 6 upstairs and downstairs, I plug in 6 upstairs and downstairs here. I get 3 to the 6th divided by 5 to the 4th. And so, respectively, I end up with C, 2 to the 7th divided by 5 to the 4th over 1 minus R, 1 minus 2/5, and so plus C, 3 to the 6th divided by 5 to the 4th all of that divided by 1 minus 3/5. So if you simplify things, I pre-computed this, 2 to the 7th divided by 3 times 5 cubed plus 3 to the 6th divided by 2 times 5 cubed. If you want to simplify those calculations, you get 128 divided by 375 plus 729 divided by 250.